We've been working with strings quite a bit in our classes. We've just really not delved into some of the deep dives of strings. So we do know this is a multi-line string. This would be a single line string. If you want to have an empty string, I just assigned it to this vowel. Do I have to assign it to the vowel? Well, yes, I have to, because well, then what's happening here? I'm assigning an empty string to the vowel, yet this is getting an L for the input, and if any of these things are in here, I'm supposed to add whatever this vowels is to 1. So what do I end up with? Well, let's take a look at that. Let's look at the difference between strings and other types of things. So let's see, 1, 2, 3, 4, 5. Oops, I need some vowels. 1, 2, 3, 4, 5. Oh, I did that wrong, didn't I? So it picked out the vowels. So what is it doing here? Well, if it's this one, this one, this one, this one, or this one, we're going to take this empty string and concatenate whatever vowel we found. Now that looks like a 1, but it's actually an L. So if the letter, and I probably should change that because it's not very easy to see that that is indeed an L. So there's no reason, I think I put an L in there just because it was shorter. But I'm going to put letter, L-E-T-T-E-R. Let's just do that. There. That makes it very long, but that's easier to understand. If the letter is this, or this, or this, or this, or this, well, then we take that letter, whatever it is, we add it to our string, which is concatenation, and we end up with that vowel down here. Okay. Well, that's pretty good so far. We're comparing strings, no problem there. We're looping through 5 times. That's one way to go through, loop through a string. It's just like a list in many respects. It's a sequence. Let's look at this piece here. Now here's a new operator. For I, in range of 5, right, we have the vowel again. Okay, so this means we're going through the same range we did before. I don't know why I didn't put an underscore in this one, because in this case we're not using that variable. So in Python, the convention is to use an underscore when you're not using the counter variable. This is the same program. But instead of having our decision way over to here, we're looking at is whatever letter we've typed in this string. If it is in this string, then we concatenate that letter onto the vowel. So that's a lot shorter. So the in operator is pretty handy. Let's look at some of the other ones here. We have string length, right? So we enter a string, the len function returns the length of the string, so we know how long it is. And then basically we do another one, and we find out how long that is. Okay, so here is our own length function. This is the built-in one. We created one on our own. Well, how does this work? So if the sentence is blank, we return a 0. Okay, well, it's not empty. Else we return L, or 1, plus the string length and the sentence. So how does that count the string length? Well, as long as the sentence isn't empty, we add 1 to this, which is returning a integer. 1 colon and nothing over here means that if the word was, and let's just put it down here to display this a little better, if the word was frog, right? So if we're going to slice frog, which the colon is a slice operator, we've used it in lists before, if we do colon 1, like that, we are including everything from the number 1 position forward. So this would be our OG, right? Because we're slicing off a piece of it. Well, then we take this sentence, because we sliced off a piece of it, we return it, and we call the string length again with it sliced off. So the next time we return OG. And the next time we return G, and then finally it's empty, and we end up with 4 for the length of it. So both of these work the same way. This is how we can build it ourselves. I don't know that that's how they built it in Python, but this is one way to do it, and it is recursive, meaning as we start, the string length is going to be, there's at least we know at this point there's one character because we got past that test. So the string length method is going to work on ROG, and we add 1 to it because we know we have at least one character. The next time around, we're bringing in ROG. Before we return the answer, we're slicing off the ROG, and that gives us 2, and then 3, and then 4, and then we're done. Now there's other things we can do with strings. Well, here's a handy one. We can do, there's all of our words, and we have fruit as a banana. We're going to print it. We're going to say length of the fruit minus 1. Well, why do we need the length of the fruit minus 1? Well, remember, indexes always start at 0. So if the length of fruit, 1, 2, 3, 4, 5, 6 is 6, we have to have a 5 because that's how far we're going to go. So we're going to go through one at a time. We're going to subtract an index, then we're going to print it out. Then we're going to take this and join a blank string because the join method has to have a string. We're going to join the reverse part of this, and we end up with banana, anamba, anamba. That's weird. This is how you do it manually. This is how you do it with the method, or function in this case. No, it's a method because we have to have a string to operate on this. Well, there's another one. So now we're going to do some slicing. Well, if we start from here and go to 3, what are we going to have left? Let's just see. So if we start from the beginning and go up to 0, 1, 2, never include 3, right? This one starts at 1, 0, 1, 2, 3. It includes that one, goes to the end. And in this case, we are doing it in reverse, just like we did with lists. This is the step indicator. When you do this with both of these empty, you're slicing the whole thing. So you return a copy, and slicing returns a copy, by the way. When you do minus 1, the increment goes backwards. So then we end up with a reverse version. So slices are pretty handy. You can slice things apart, put them back together. So we slice these two guys apart, right? Well, if we store those as variables, we can then put them back together. So for example, let's pull this guy out of here and not just print it. Let's just put it here, and we're going to create a variable of ban. Is going to equal this because that's what it's going to equal. Then we'll print ban, right? Same thing that we just did. It's not printing the word ban, it's printing what's stored in the variable ban. So we could have this one also be ban, but we'll call this one ban2. It can be whatever you want. All right, so now we print ban2. So now we've taken it apart. What do we want to do next? Well, let's put it back together. So let's end up with ban3 equals, how do we put strings together? We can concatenate them. Ban1, ban plus ban2. Right? We could also, that would put it back together the way it was. Maybe we wanted to put it back together this way. So you can take things apart and put them back together. In this case, we took it apart in the middle and stuck them back together the other way around. So let's print ban3. See what that looks like. Well, it worked. Anaban, ban, ana, anaban, anabum. So, yes, lots of good things you can do there. We're going to do some more slicing. This is an example of Grace Brewster Hopster. She's one of the big names in computing. She worked on some of the first computers. She's the one credited with finding the first physical bug inside of a machine. So if we're going to take her name, if we start at 0 and only grab the first one, we get her first initial. Well, how do we find the second initial? What this does is the index operator finds the first space character. That gives us the location of this space, 0, 1, 2, 3, 4, 5. So then how do we find the middle initial? Well, we do what we just did. So that'd be 6, right? And we just want to go one more to get B. Okay. Well, we can find the index of the last character. So right index means it's going from the right. It finds the index of this. And the same thing. We find that space. We add one more to it. We get the initial. And then we convert Grace Brewster Hopster into G5B14. So what's the 514? That's the index of the space. There's her initials put together. So there's a nice one with using initials, splitting. And this one has a problemo in it. Let's see here. You can also split things up by using the split operator. Much simpler, isn't it? So if we did this last one like this, we'd just put in a space in here, right? Yeah. If we wanted to extract each part of these, we would say split it up into 3. This is a list. And we do 0, 1, 2, 0, 1, 2 because 0, 1, 2. Then we have each of these independently to work with. There we go. We pulled it all apart. And we didn't put it back together, but we did pull it all apart. Let's see, what else do we have here? Let's look at this one as the last one. This is the last assignment. That's actually a tutorial. We're going to do some secret messages. So here is our normal alphabet, including spaces. A substitution cipher means that whenever we type in an A, the cipher is going to convert it to an X. So this is our cipher key. If somebody types in a space, well, it's going to return a space. If somebody types in a B, you send a Z. So we're going to enter our secret message. We're going to put it all in lowercase so that we can use our little cipher conversion. Here is going to be our encrypted message. It's a blank string. For each character, which there are not really a character variable, we're going to find out, is it a letter or a space? Okay? Because we're only dealing with letters and spaces. We're not dealing with numbers and all the other things. We just want letters. We just want the spaces. If it is a letter or a space, we're going to find the index of that character. So if we type in a B, the index is going to be 0. So these are parallel lists or parallel strings. Lists, same thing. They're a sequence. Now we know that A is going to be 0. So there it is, 0. Right? Cipher key, we get 0. We can concatenate it onto the secret message, and there we go. If the character is not a letter, we just add it on and we don't change it. So that's how we encode it. So let's take a look at the encoding first. So my secret message is Bill, and there's my scrambled message. Well, let's decode it. Ta-da! What did I have to know how to decode? I had to have the cipher key. So how did I decode it? Well, I'm going through the encrypted message one at a time. Is it an alpha? Is it a space? I find the index. This time I use the alphabet to reverse it, because the alphabet is what I'm looking for. And I found the index of the N, for example, here, and then I went up and did a C. Now there's another famous substitution cipher called the Caesar cipher. That would be a nice challenge for anybody to do. Caesar cipher is a classic cipher program. There is a little assignment at the end of it. It's not very hard, kind of a review of some of what we've done before. That is our brief tour of Python strings.